Okay, guys, good morning. We could turn on our cameras so I can see your lovely faces. That'd be great. Hi, good morning. There's all the faces. I love the faces. The faces make me happy. I get to stare at screens all day. Any faces, okay? All right. So, before we start anything, what should you have already done today?
Attendance.
Attendance. See, it's like y'all get annoyed. I love that you know it so well that you're annoyed by me. That's perfect. It's gonna be great. Okay, so you should have already done the attendance link. What else do you see in the top right corner of the screen I shared with you? What's right here? Anybody?
Retake deadline.
Yes, so there are already people in this room who have completed all the requirements for the retake. And when you complete all the requirements for the retake, your unit retake test will magically show up in your Unit 1 retake module. Can y'all hear me, or is it choppy? I'm hearing a little bit of feedback.
You're fine. My attendance thing isn't loading. It says
Okay.
the account's google.com is refused to connect.
Yeah, are you in your Allen ISD email? Because it's
Yes.
Okay. Well, then just give it a minute.
Canvas.
Give it a minute, and we'll try again in a minute, and let me know, okay? But yeah, I'm sorry. I was hearing feedback, so I wanted to make sure I wasn't a robot to you guys. Yes, the Unit 1 retake deadline is next Friday. There are already people in this room, in this little Zoom room, that have successfully completed all of the requirements. They did all of their Canvas. They came to tutoring and did the retake assignment, and I have assigned the Unit 1 retake to you. In the retake test, there is instructions on how to sign up with the virtual testing center, okay? So go to the virtual testing center, sign up, and they will open your test for you during the appointment, okay? Are there any questions about that? As soon as you submit that retake assignment, which you only get after you come to tutoring, which the people that came to tutoring, I was not that bad, they can tell you, right? Take it from a student, not from me. But yeah, we already have people that are taking the retake like Monday. So get on that if you want a different grade, okay? All right. So we are doing isotopes. So I'm going to use my magical name picker wheel per usual. Here it is. Bum, bum, bum. Let's see who it picks first. I get to talk to Caden today. Caden, you're first. Hi, Caden.
Hello.
And I saw your email, and I'm going to check that today just because you happen to be the first one called. So, tell me, what is this number on the oxygen?
That's the mass number.
Okay, so what makes up the mass number? What is the mass number counting?
The protons plus the neutrons.
Right. So in atoms, we have decided that protons and neutrons both have 1 AMU, which means 1 atomic mass unit. So each one is equal to 1 in weight. So when we have the mass number, there are 16 items between protons and neutrons. Okay, it's just those two numbers added together. Where are protons and neutrons in the atom? Allison, where are protons and neutrons in the atom?
In the nucleus?
They're in the nucleus, right? And remind me, oh, I get to click the wheel so much today. I'm so excited. Eric, are you here?
Yes.
Awesome. Eric, what is the atom mostly space or mostly mass?
Space.
Yes. So that nucleus is very, very, very small in the center, the size of a blueberry in a football field, right? Very, 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 very small, but it has all of the mass. So it's this super dense, super heavy little chunk, okay? Electrons, do they have mass? Aiden, do electrons have mass?
No.
No, sorry, I was grabbing my little tablet. No, they do not have mass. So which two subatomic particles could change the mass number? Augustine.
The protons and the neutrons.
Beautiful. Thank you. So protons and neutrons are the only ones that can change mass. Katie.
Yes.
Are we allowed to change the number of protons of an atom and have it stay the same atom?
No.
No, we can never touch the protons, right? As soon as the protons change, it's a whole different thing. It'd be like changing your DNA. You'd be just like someone else, right? So protons determine what it is. So two nickel atoms, two oxygen atoms, two zinc atoms, whatever it is, what makes them the same and what makes them zinc or nitrogen or whatever it is the number of protons. It's the identifier, right? It's the identity. You can't change their identity. So what is the only mass-bearing particle that can change in the atom? Z.
The neutron.
The neutron, right? And what do we call atoms that have the same number of protons and different number of neutrons? Gurinder.
Sorry, what was the question?
What do we call when atoms have the same number of protons, different number of neutrons?
What
What is the word for that? Do you know?
I'm not really sure.
Okay, so in your notes, it's the word that started with ISO. ISO.
I can't.
Isotopes?
Isotopes, right? Isotopes or isotope, all right? It's because you can change the number of neutrons in the atom. They can be different weights. So this is like saying, like, if the protons are the DNA, that's who you are, right? If I gain 5 pounds, I'm not a different person. I just gained 5 pounds, right? If I lose 5 pounds, I'm not a different person. I may feel like a new person, but I'm the same me, right? So protons keep the identity. Neutrons are just like gaining and losing weight for the atom, okay? And that's what isotopes are, just different weight versions of the same atom. Throw in the chat a scale of 1 to 10 of how we're understanding this right now. Let me see those beautiful numbers. Love it. Okay, good. Seems pretty good. So we're going to go back to what I asked Caden all the way in the beginning. I'm not calling Caden again, but he is the one that gave me an answer. So Yadvi, he told me that this was the mass number, okay? And it was the protons plus the neutrons, right? Okay, so what is this bottom number right here? What is that?
The proton.
Hold on. I asked Yadvi. Let her answer. I love that you're excited though.
The protons.
Yes, it's called the atomic number and it's the number of protons, right? The number of protons and the atomic number. So the magic question of the day, okay, that's going to drive a lot of our information today. Let's see who it's going to call. Shiv.
Yes.
If we know that we have 8 protons, we know we have 8 protons, how do we tell the number of neutrons?
By subtracting the number of protons from the mass number.
Yes, I can tell you were very excited, and I can tell that I very much messed up this line right here. Okay, so you just subtract. So when you see these problems, it looks just like a subtraction problem for the number of neutrons. Protons and neutrons minus protons equals neutrons. So Shiv, how many neutrons do I have?
8.
I have 8. Beautiful. Love it. All right. Here's the slightly more challenging question that will not be challenging at the end of the day. Remember, today's hard stuff is tomorrow's easy stuff, but it's going to be like 5 minutes later easy stuff. So it's even better today. Okay. Carter. How do I tell the number of electrons?
It's generally even with the amount of protons.
Right. So what we're going to look at is right here. Hold on. Let me get a different color so you can see. Okay. Right here. If there was a charge, there would be a number. You would see like 2 minus or 1 minus or whatever, but we don't have that. So what that means is that, okay, so we said protons and neutrons have mass. Remind me, which ones had charge? Hold on. Tim, which subatomic particles had charge?
I think it was the electrons.
The electrons and the... Yes. Be confident. Say it now. I want you to say that again, like you knew it the whole time and you were 100% confident. Go.
The electrons and protons.
Yes, that's how I want answers. Okay, whether you're right or wrong is how I want you to say them. Okay, so it's the same because every time we added a proton, we had a +1, right? We had a +1, +1, +1, +1, and we did that 8 times. I ran out of space. Oh, hello. That was scary. Okay. We did that 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we did that 8 times. So for this to have no charge, we had to have 8 electrons to cancel it out. So whenever you see a charge, it does not mean that that's how many electrons it are. It means that's how many electrons we are winning by. If you see a positive number, it means the protons are winning. Okay, scale of 1 to 10, how you understand that? Give me a thing. And remember, you can always drop it private if you need it a little bit. If you are a little bit not wanting to blast it publicly, I just want to know the honest answer. I flubbed over my words there for a second. Okay. So next one, I'm going to have someone tell me the whole thing. Brooke, phosphorus, P. Okay, Brooke, tell me the data, all of them, all 3 of them. You drew
15, 16, and 15.
Dude, you didn't even hesitate. I love that. See that confidence, guys? I want everybody to be like Brooke. Okay, what would Brooke do? That's gonna be your new bracelet. Okay, so we had 15 protons. How did you know?
It's the same as the atomic number.
Yep. So the number of protons is right here. Neutrons. What did you do?
It was that number minus the mass.
Yep. So the mass number 31 minus 15. Subtract these 2. And you get this guy, okay? And how did you know the number of electrons?
There's nothing saying either like plus or minus at the top right.
Yep, they have to be exactly even. They have to be tied in the tug of war. Love it, okay? Amir, do zinc for me.
The P? Oh, the whole thing?
Do the whole thing, yes, the whole thing.
The first one is 30.
Okay, good. Where did you get that?
The below it, and then you subtract it by 65.
Yep, you subtract it and you get what?
25.
I'm gonna help you out there with the mental math. It's 35, but yes.
Yeah, sorry.
That's okay. Mental math and calculator errors are better than how to do it errors. We can fix a calculator or mental math. How to do it is much harder to fix. So that's the mistakes you want to make, okay? Electrons. How
30.
many? How do you know?
Cause it's, I just kind of know.
Okay, awesome. I want everybody to try these guys. Everybody to try these guys real quick. Real quick. Just to make sure we got it. You guys are 30 seconds to a minute.
I have a question.
I have an answer.
Are we gonna learn things about like quarks and stuff or no?
That, we're gonna mention they exist. That is very much an AP IB thing and physics thing. So it gets quantum numbers and quantum energy levels and spins and why electrons are negative and why protons are positive and the mixture of partial charges is a little bit dense for an introductory course. So this is like year 1 to the advanced stuff, if that makes sense. It's like a pre-advanced stuff. That's why it's called pre-AP. Okay. But I love that you want to know about that. And if you guys, if you ever want to know about that, feel free to come to a tutoring and I would love to discuss all the quirky things with you. Okay. Okay. Because it is super interesting. So Abigail, what is the only, why you? Because I wanted to, the wheel chose you. All right. So what is the only difference between these 3 atoms?
On the first one, obviously we know that the atomic mass carbon is 12, and as on the other 2 examples, it goes up by 1, which is why 12 plus 1 is 13, and on 12 plus 2 is 14.
Okay.
Which is why we see that it's going to have and it's gonna be an isotope. due to having an extra proton.
Yeah, so the one thing that we're adding is a neutron, right? Because we can't change the number of protons. So protons can't change. So if we're changing the mass, all that's changing is the neutrons. So these are isotopes of each other. We have 6, then we have 7, then we have 8. They're all neutral, so the electrons are still the same. Okay, so now I want you guys, and we already did this, okay? I want you guys to go to your Canvas, and I want you to open the warm-up activities and open up this guy, okay? I fully understand that a key exists, okay? The key is already posted for you, but don't pull up the key because I want to make sure you understand this, and we're going to do some stuff together. And if you pull up the key, yes, you will sound really smart to everyone in the room, and you'll only be proving you don't value your own learning to me. So if you want to actually see if you know it before you get to the test and have to do all the weird stuff for the retake, just make sure that you're doing the one without the key so that way we can really see what you need to know, okay? Because I love to help you, but I can't help you if you're looking at the key. The key, view that like if you are one of the people that gets the teacher version of notes, there are select few throughout the class for a variety of reasons. And by class, I mean everybody in pre-AP in every class ever. That's like the teacher version of the notes for you, okay? You know who you are. If you don't know what I'm talking about, then just ignore me because it's not you. Okay? All right, we're pulling it up. It should look like this. This should be the top half. Okay, so who am I gonna pick on now? So many people to choose from. One. Hello,
Yeah.
friend.
Yeah.
All right. First question. What is the identity of the element? Don't worry about the hyphen notation. Which atom is this, and how do you know? Notice I said you also need up here a periodic table. So if you don't have one printed, go to ptable.com in another tab. We're going to use it a lot today. Okay. So, 1, how would you tell the identity of this element?
The number of protons.
Number of protons. How many protons does it have?
28.
So what is its notate? What is the name of this element? What is it?
Nickel.
Nickel. Beautiful. Okay. When I say hyphen notation, what's the only thing that's changing about the different isotopes? Is the number of protons changing? Everyone shake their head like this because the answer is no, right? Number of protons aren't changing. It's the mass number that's changing, just like we saw here. The only difference between these, go back, was the mass number, okay, the mass number. So if the mass number is the only thing that changes, that's what we want to tell other scientists, right, is what we were dealing with. So what do you think goes right here after the hyphen? We know this is the number of protons. This told us it was nickel, right? How do I find the mass number? Wait, I didn't call anyone, did I? That's my fault. What am I doing? I'm talking to no one. Jamie, how do I find the mass number?
Add protons and neutrons.
Yes, that is it. See, say that again with confidence. We're going to practice y'all's confidence. Say it again with confidence.
Add protons and neutrons.
There we go. So we add protons to neutrons. We add these together and we get the mass number. So when I add them, what do I get? 28 plus 30 is, why is it doing this to me? 58. There we go. All right, 58. So now the chemical configuration is what this is. Okay, mass number on top, atomic number on the bottom. So we know that nickel from the periodic table, when you looked it up, is Ni. So which number goes on the top? Mukunta, which number goes on the top? Which number goes on the top? Are you here? Yeah, I see you. Dun, dun, dun. Asked to unmute. Unmute.
Yeah, 1 sec.
You're good. Which number goes on the top? I'll give you some help here, okay? Which number goes on the top? Take a look at the screen.
The mass number, so it's
So it's
58.
Yep, so the 58 goes on the top. Okay, 58. What number goes on the bottom if we write it? Because sometimes we don't have to write it. Notice right here, we don't have to write it. But here, if we wanted to write it, because we know what it has to be, right? But for posterity's sake, it would be 28. Okay, so if you write it, it's down here. The mass number is down here. The reason we might not have to write it is because there's only one thing nickel can be, and that's 28 protons, but that's okay. All right, try the next one. Try number 2. I'm gonna give you guys about a minute to try it. And then I'm gonna call on people to tell me what you wrote. And if you haven't been picked yet, the wheel is getting smaller, so the chances are getting larger that you are going to get called on. I'm actually gonna make it through every single person today, I think. I'm very excited about that. About 30 more seconds. Okay. Olashan, good morning, friend. Tell me what you would write for hyphen notation.
Cadmium,
Yep, cadmium. Yep, cadmium. How'd you get cadmium?
because the atomic number is 48.
The atomic number is 48, so that's 48 what? Protons, right?
Protons.
All right, and then what do you write after the hyphen?
112.
Right, because the mass number is the only thing that can change, so that's what we write. Beautiful, you did that perfect, and I love it. Thank you so much. But heck, hello, good morning. We already said this has 48 protons, right? Because that's the atomic number. How many electrons and neutrons does it have?
48.
Has 48 electrons. How do you know?
Because it's the same number as protons.
Yeah, it's neutral, right? There's no charge, no charge. So that means that electrons is equal to protons. There's exactly the same amount of each, positive and negative. The force is exactly balanced, okay? Mace Windu would be pleased. How many neutrons does this element have? Wait, I didn't call on somebody. Ha, hold on. I did that twice now. What is wrong with me? Zach, how many neutrons does it have? And if you're not sure, give me a good guess. Hold on, who's in the chat? Is that you? Oh, you don't have a mic? Okay, type it in the chat, dude. I got you. I will narrate. How many neutrons do you think it has? Someone's jamming. The great thing about Zoom is it lights up and it tells on you. Yeah, 64, because we subtracted 48 from 112, and that gave us 64. Beautiful. All right, so now we're going to do something a little funky, okay? So we're going to look at nitrogen. Oh, you dropped your mouse. Oh, it's so sad. No. Okay, guess what? It's time to Amazon. All right, so now let's take a look at this nitrogen. The mass number's not changing. Okay, the atomic number is not changing. What's the only thing that's changing in this next problem, Eric Brooks? Wait, I already called on you.
Oh, okay.
You're okay. No, go ahead. You're good. Go ahead.
Is it the electrons?
Yes, the electrons are changing. We can't change the protons, right? So what's changing about these elements? The electrons must be changing. So the way that my professor wrote this that I really liked is that he wrote, okay, so protons, you may want to write this somewhere, and neutrons, these ones have mass. Okay, and he wrote it just like this. Protons and electrons, these ones have charge. So you see, proton is the only one that has mass and charge. Okay, electrons only have charge, neutrons only have mass. So if the charge is changing, what's the only thing that could be changing? The electrons, right? If the mass is changing, we already determined that's the neutrons. This is why. So what has changed about these elements? It would be the electrons, okay? The electrons have changed. So, or the charge. I answered both of these to begin with my answer. So we're just gonna put that here too. So when we have charge of 0, a charge of 3 plus, and a charge of 3 minus, which one has the most electrons? Rafid, which one has the most electrons?
The 14 and 3 negative.
3 negative, because it means the electrons are winning by 3, right? So it means if we drew them all out, the electrons are winning by 3. Doesn't mean there's 3 total. That is one of the most missed questions about ions, okay? The number isn't the number of electrons, it's the number it's winning by. It's the margin, okay? So if you were playing sports, you said, oh, they're up by 1. It doesn't, you don't know what their score is, but you know it's 1 bigger than the other guy, right? So we're up by 3 on the electrons. So bonus question, because y'all are smart cookies, how many electrons does that 3 minus have, Shivani? How many electrons must it have? This is a hard one. You're good. It's going to be easy in about 30 seconds, but it's hard this second.
I'm not sure.
Okay, so what do we know about nitrogen? How do we, so if it was neutral, what would we look to tell how many there is?
The atomic number and atomic mass.
Okay, so what's the atomic number of nitrogen?
Give me a second.
You're good. We can wait.
7. So then that would be 14 minus 7, which would be...
Well, that gives you the number of neutrons. I'm asking electrons. So atomic number is 7. So for this neutral atom, how many electrons do we have? If our protons are 7, what must our electrons be?
7.
So when I have plus 3, it means I'm not neutral. The electrons are winning by 3. So what do I do to the 7?
You add 3, so then it would be 10 electrons.
Yes, beautiful. 10 electrons. Now here is the next tomorrow's easy question. Okay. Dude, there's only 3 people on this wheel. We are doing so good. Okay, Shahed, how many electrons does the 3 plus have?
The 3 plus has 4 electrons.
Oh my God, you did that so fast. I'm so proud of you. I'm colored impressed. Okay, if there was a color, it would be impressed. Tell everyone else how you got there.
So there are 7 protons. There are 7 protons in the nitrogen atom, and neutral charged nitrogen atom usually has 7 electrons. So if there's 3 positive charge, that means there are 3 more protons than there are electrons. So 7 minus 3 is 4.
Yes. Oh my God. You could have taught class. You sounded all professory. I loved it. Okay. So we can't change the number of protons, right? Most kids, they'll not remember that part, right? They're like, oh, protons are winning by 3. There's 10 protons. That's where their brain goes. That is not true. We cannot change the number of protons. So if protons are winning by 3, it means electrons have to be behind by 3. So you have to subtract. So beautiful. That was so, I'm so impressed. I loved that so much. Okay. All right. Scale of 1 to 10, how we're tracking. This is a lot of nitty gritty. Oh, look at all that confidence. Look at you guys. Love it. Okay, let's try this. So for carbon, we already did this in the warm-up, right? These are what we called isotopes. I did this for you guys in the warm-up, so skip this part. Ooh, hello. skip this part. Okay, we're going here. So we are going to do this line together right here. Okay. Actually, let's do this line. We're going to do this line together. Okay. So that's what I did for the last class. Let's take a look at what we know. Mass number is 129. So what is that? How do we get the mass number? We're going to call on every person here in just a second. 2 more people. Anshuman, what is in the mass number again? Remind me.
You just add the protons and neutrons.
Right, so we know that this, hold on, where'd my pen go? There it is. We know that this, there it is. Ha, I found my pen or tip. It's so hard to find sometimes. We know this is protons plus neutrons, right? This charge is 2 minus, right? 2 minus. So what do we know about the charge? Last person, Nihal, you got to the very end, last but not least, okay? What is?
So there's more electrons than protons?
Yes, electrons are winning by 2, right? Electrons are winning by 2. So if I have 54 electrons, how do I use this number to determine the number of protons? And we are going to start over. Everybody talk today. How exciting is that? I am super stoked. That's a first. Everyone clap. It's so great. Not really. You don't have to clap, but we'll start the wheel over. Mahek, how do I use that information that the electrons are winning by 2 to find the number of protons? They're winning by 2, right?
Yeah.
So what must be true about the protons? There's 2 more electrons than protons.
Can you repeat the question?
Yes, absolutely. How many protons do I have if electrons are winning by 2?
Oh, 52.
Yes, that is perfect. Look at all that. Some confidence, girl. 52. Okay, 52. So now everything else is going to start to fall in place. So next person. Gurinder, how do I tell the number of neutrons that I have?
Do you subtract the number of protons?
Yes. So minus 52 will give me this guy, right? Because this is protons plus neutrons minus protons. How many protons do I have? 52 subtracted from 129. What does that number come out to be? Fancy math.
Are you still asking me?
Yes, I'm asking you. Sorry, I should have been more specific. That is my bad.
77.
77. Love it. Okay, so we have 77. So now everything else falls in place, right? The only thing we have left is to name the atomic number, which should be super simple. Nihal, you were last this time, not anymore. You get to go twice in a row almost. That's exciting. How do I tell the atomic number?
It's just the amount of protons.
Yep, the atomic number and the number of protons are the same, right? So this has to be 52. And last, you are going to have the most involved answer, but hopefully you've seen it's already today's easy thing. It was like 5 minutes ago hard thing. Shahed, man of the hour, tell me what the nuclear symbol would look like. It would be which element? You sound like a robot, Bub. Can you type it?
P2.
Oh, there we go. So the atomic number 52 is for tellurium, right? Oh, why does it keep doing that? That is so annoying. There it goes. Tellurium, okay. My handwriting looks messy today. And you said the atomic number was on the bottom. So that's 52. What is happening? Why is my pen being silly? Hold on, guys. Sorry about that. So 52, and that this is 112, or not 112, 120. So sorry, guys. The pen threw me off. But yes, you were right. It was perfect. You did everything just right. I don't want to do that. Okay, y'all get it. I don't know why it's doing that. No, come back. That's so sad. Here we go. So just to put all that back, it was, it crashed. Sorry, guys. It was Tellurium. Okay, we had 52, 129. We said it had 52 protons because the electrons win by 2. It had 77 neutrons. The atomic number was 52. And we knew the number of protons because it was winning by 2. Beautiful. This line, try this. This is the last thing we're going to do. Okay, I want you to try this line on the top one, the one with iron, this guy. So we're doing the exact opposite of what we did last time. Okay, we're doing this guy. Okay. Try it, and then I'm going to call on lots of people. There we go. Okay, y'all are doing great, by the way. I hope you feel like you're doing great because you are. Okay, top one, we're working on it. All right, Zach, what is the first thing you filled out and why? Zach. For the top line, this one, the one with the star, the top line, right here. What did you fill out first? Protons is 26, right? Because that is the atomic number. So we could write that both under atomic number and protons. Beautiful. Thank you so much, Zach. I know it's annoying when you have to type. I appreciate you doing it. All right. Kaden, what's the next thing you filled out?
I filled out the neutrons.
Okay, how did you find the neutrons? What did you have to put in first?
I did 58 minus 26.
Right, 58 minus 26.
And it came out to be 32.
32. Okay, beautiful. Thank you so much, Kaden. That was perfect. Okay, Amir, what could you fill out now? What's the last piece of information we haven't used?
The last piece is the is it the symbol?
The symbol is iron, but right here, what have we not used yet? You know what I'm circling?
Oh, the charge.
The charge is 3+, so how do you use that piece of information?
Don't you add it?
So 3+ means what is happening in the atom? Which subatomic particle is winning? Whoa, I do not know what's happened there. Ooh, okay. Which subatomic particle is winning?
The F, I forgot what it's called. Hold
Okay,
on.
so which subatomic particle is positive? Which one has a charge of +1?
Positive.
So is it protons, neutrons, or electrons that have +1?
Proton.
Yes. So which one has to be winning by 3?
Neutrons.
So if it's 3+, neutrons have no charge, right? Electrons have negative, protons positive. So which one has to be winning by 3?
Oh, the electrons.
The electrons would be negative. So if it was 3-, electrons would win by 3, right? If it's positive, who do we know is winning?
Protons.
Yeah, so if it's 3+, it means there's 3 more protons than electrons, okay? So we know we have 26 protons. Can you change the number of protons, Amir? Can you change the number of protons and have the atom stay the same?
No, because wouldn't it change up the whole thing?
Yeah, it would. That's exactly right. So if the protons are winning by 3, it means there has to be 3 less electrons.
So it'd be
Right?
23.
Yes. Beautiful. You got there. Give yourself a pat on the back. That was wonderful. Remember, I told you guys that every single thing y'all say is valid, whether you are confident from the beginning or whether you need some adjusting. That is my job. And every time you let me guide you to an answer, you validate my employment and let me get paid. So thank you for paying me and feeding my children. Okay. So your questions literally are my lifeblood. So thank you for that. I love that. That back and forth probably helped so many people in the room that didn't say anything or speak up. So that was a very good thing. Okay. So give me a scale of 1 to 10 how you're feeling on this. That was the last example we were going to do together. There's more examples in the workbooks for you to try on your own. Beautiful. So what do you have left to do? What is there? What is life? Okay, so where do we go to find out what we have left to do for anything ever? Everyone spacebar. Canvas, right? Oh, we love Canvas. It's your favorite. I can tell you're so excited. Listen to all that excitement. It's the best. So you go to Canvas, you go to modules, okay? And we see, first, I want to point out some things. I minimized this so I could show you the Unit 1 retake module, okay? Step 1, you need to complete all units in Canvas. Step 2, you attend tutoring with me, and there are people in here who can tell you I didn't bite anybody, it didn't hurt, there was no pain involved, it was all right. And step 3, you complete the retake assignment. Once you complete this assignment, which is only assigned to you once you go to tutoring, this opens up. So there are some people in this room that already have this showing and they can schedule with the testing center. In the retake, it shows you exactly where to schedule in the testing center. So I'm showing you this one more time just to make sure. See how it says, do this. This is how you schedule your test. You are responsible for doing it, not me. If you are eligible for a retake and never schedule your retake, that is not my fault. Be a responsible human, okay? Thumbs up if we understand. Responsibility. Beautiful. I made it very easy to find. Hopefully, that was the goal. Okay, so let's go to the module for this week. Take a look at these beautiful due dates. Aren't they so nice? They tell you when everything is due. And what started in Unit 2? What started in Unit 2? Told you someone is going to forget.
Late grades.
Late grades start in Unit 2. I know I'm not excited that some grades are going to be late. I'm excited that y'all are remembering that late grades are here because there's going to be.
Tell me when they're gonna.
What was that? Go ahead. I missed that. Okay, you broke up.
Oh, sorry, my mic was on. I didn't realize it was.
Put it in the chat because you're breaking up and I'm having a hard time understanding you and I want to answer you. Okay, so I'll pull my chat up. I'm going to keep talking while you do that. So due to class prior today, you should have seen nuclear symbols and components of atoms. So this should have just been reinforcing all the things you already saw. If for some reason, I know that nobody would ever skip the notes, but if for some reason you skip the notes, go back and watch them now that I've explained them. So that way you can get a really good understanding. And also look what you have to do before midnight today. Notice today is the 11th of September. Okay. So you have QC 2.1. Okay, QC 2.1. Do that by midnight tonight. Midnight tonight, okay? Before next class, you have a lab, okay? Beads in a baggie lab activity. You have to do both of these. There are people that are not submitting both. So make sure that if it's on here, you're submitting it. It's under the due date. It is therefore needing to be submitted, okay? For calculating average atomic mass, we are doing that next class. So please watch this because it's math. It's math. So if you know that you struggle with math, it's a very good idea to watch something before coming to class because the way your brain learns, especially difficult concepts for the way your neurology happens to be made up. Remember we talked about fish climbing trees. If you're a fish climbing a tree in chemistry and you really want to climb the tree, but it's not your natural talent, the more exposures you have to a concept, the more number of times it goes in front of your face, the more likely you are to be successful. So if you watch that video before you show up, it's going to be the second time you've seen it, and you'll know how to ask questions better for me to help you. Okay? So especially if math is scary for you and you're one of those people that it gives you a little knot in your stomach, it's really important you watch that first. Okay? Even if math is simple for you, weighted averages is something you haven't done since 7th grade. So please watch it. Okay? 7th grade TEKS, at least last time I taught math, it was 7th grade TEKS. So, do you guys have any questions for me? Anything at all? I'll even open up to personal questions because y'all got done a little early. Do you just have like a weird random question you want to ask me? That's okay too.
I know that electrons do have like a very, 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 very little amount of mass. Like
it's called negligible. Negligible. So the concept of negligible is like if I put food coloring, a drop of food coloring in the ocean, did I technically put food coloring in the ocean?
Yeah.
Absolutely. Is it going to have any visual effect?
No.
No, it's negligible. It doesn't actually make a difference in any calculation ever. It's like e to the negative 24 mass of something. So it's insanely small. Yep. That was a very good question. I actually super duper loved that question. Thank you. Anything else? Last chance. Last chance. Okay. I hope you guys have a fabulous weekend. Do me a favor. Do me a favor. Make sure this weekend you ask your parents where they were on September 11th if you've never done it. Just listen to the story, okay? Just as a human. As a veteran, someone that was in the military and as a human, it's a very interesting story. So if you've never asked your parents, promise me you'll ask that this weekend, okay? Okay. All right, guys. I will see you next week. Sleep well, friends.